This is a revision video for energy stores and systems. There are 8 energy stores: chemicals such as batteries, fossil fuels such as coal, oil, gas, mussels, food, and this is the energy stored within the chemical bonds. Kinetic energy store is anything that is moving. Could be from a tiny particle to a whole asteroid or comet through space. But the key thing is it's got to be moving. Gravitational potential energy store is anything off the ground. Elastic potential energy is anything compressed, stretched or twisted. Thermal energy is how much internal energy an object's got. Everything has got internal energy. The hotter it is, the more thermal energy, the more internal energy it's got. For example, an ice cream has got a very low amount of internal energy, a low amount of thermal energy, whereas a hot cup of coffee has got a lot more. So the hotter it is, the more thermal energy. And we'll come back to thermal and internal energy when we do particle model revision. Nuclear energy, that's the energy stored in atoms' nucleuses, or atoms' nuclei for plural. Magnetic energy store, that's the energy stored between attraction and repulsion, so between poles of magnets. And electrostatic is between charges. For example, attraction between negative and positive charges, or repulsion between like charges such as negative, negative, positive, positive. There are specific examples of systems that you need to know about, such as an object going upwards. For example, if we throw a ball up in the air, it will come back down. So for example, if we're throwing it, represented by this hand, we've got chemical energy store, and we're going to use that chemical energy store up, which is going to decrease. The ball's increasing in height, so the maximum GPE is at the top. So that chemical energy store has been transferred to max GPE, which increases. But then that GPE decreases as it goes down. As the ball goes down, it gets faster and faster and faster. At the bottom, it's got its maximum speed, so it's got its max kinetic energy. Which increases. So the overall energy transfer, we can write as chemical decreases, and that's mechanically transferred to gravitational potential energy, which increases, and kinetic energy, which also increases. And I represent the increases with the arrows. For something that's hitting an object, for example, a ball hitting a tennis racket, so that's my tennis racket, and the ball comes in to hit it. The ball's moving, so we've got kinetic energy, and the kinetic energy is going to decrease because that ball's going to slow down when it collides, and that energy is going to be transferred to thermal energy. So the thermal is going to increase, it's going to get hotter, and in this instance the tennis ball would squash a little bit, so it would get an increase in elastic energy. Sorry, I can't spell increase there. If we've got vehicles accelerating, so this could be a car, it could be a rocket, it could be a bike, it's the same principle. So I'm going to use an example of a bike. So, bike. And on the bike we've got a human riding it. So the human's using the muscles, so that's chemical energy, and that will decrease, and that will be transferred to kinetic energy of the bike and the cyclist in the system. They're both going to be moving. They're going to get faster, so it's going to increase. And we're also going to have wasted energy as thermal, and that will increase too. I've just gone to the bottom of the page there. So the bike, chemical energy decreases, which increases the speed of the bike, and thermal energy is increased, which is wasted. For a vehicle slowing down, in this instance, I'll use a car as an example. So, car's moving along. The car's moving along, so it's starting off with kinetic energy. So that's going to decrease. And the brakes are going to be doing work. They're going to be doing friction. So the brakes are increasing temperature, so we're going to have an increase in thermal energy, so thermal will increase. So that's for a car slowing down or a vehicle slowing down. And the last example we're going to talk about is bringing a kettle to boil. So inside the kettle we've got a heat element that heats up. So usually in the old specification you could say things like electrical energy is transferred, but usually we use fossil fuel power stations, so it's going to be a chemical energy store to start off with, and we're going to be using chemical energy up, so the chemical energy decreases, and that chemical energy is transferred by electricity. Remember, electricity is not a store, you've got electrical transfer. The water's going to heat up, so the thermal energy is going to increase, and we're also going to waste energy to the surroundings. The heat's going to be given out by the kettle to the surroundings too, so that's going to be dissipated, so there'll be wasted energy there. And the kettle is also going to get noisy, but remember, sound isn't a type of energy store. Sound is radiated away.